Since the most ancient times, humanity has asked itself, where did we come from? Today, we dive into the answer that science offers us. The Big Bang, the great explosion that gave rise to everything. Before the beginning, what we can conceive of as nothing reigned. But this nothing is more complex than we can imagine. It was a kind of quantum void, a soup of potentialities. In this empty space, quantum fluctuations were taking place, tiny surges of energy that swarmed out of nowhere. These fluctuations, however ephemeral they were, carried within them the seeds of what would become our universe. Each of these transient particles was like a silent note, waiting its turn in the symphony of creation. And at the heart of that void, a point of extreme density and energy began to form. A singularity. Inside, all the laws of physics we know didn't apply. It was a point of potential infinity, about to trigger an event of cosmic proportions. Suddenly, that singularity, full of energy and potential, erupted. It wasn't just an explosion, as we commonly think. It was a vast, instantaneous expansion of space and time, the birth of our universe. Within fractions of a second, the universe expanded at unimaginable speeds. In this whirlwind of energy, the first particles began to form, atoms began to come together, and the first stars to shine. That burst left echoes that, surprisingly, we can still hear today. Known as the cosmic microwave background, these waves are the soft hum of the birth of the universe, a reminder of its hot and violent childhood. This sound, as soft as it is, tells a story of origin, chaos, formation, and above all, wonder. We are literally hearing the reverberations of the moment it all began. In the first moments after the Big Bang, the universe was teeming with frenziedly moving subatomic particles. These particles began to combine, giving rise to the atoms we know. As time passed, these atoms began to group together, forming the first clouds of gas. Within those clouds, a magical transformation was about to take place. Under the influence of gravity, these clouds began to contract. And at the heart of this cosmic squeeze, temperatures and pressures became so intense that they started the process of nuclear fusion, igniting the first generation of stars. These trailblazing stars weren't alone for long. They set off a chain reaction of stellar births, eventually leading to the formation of entire galaxies. The universe that was once dark and hot was now illuminated by countless stars, each a beacon of cosmic evolution. In nebulae, the nurseries of stars, the next generation of stars was being forged, and with them, the ingredients for planets, for life, and for everything we know today. The tapestry of the universe was being woven. As stars were born, they didn't stay lonely for long. They began to cluster together, drawn by an invisible but undeniably powerful force, gravity. These stars began to orbit around each other, creating cosmic dances of unimaginable beauty. It was against this stellar backdrop that the first galaxies emerged, colossal structures containing billions of stars. Some galaxies, like our own Milky Way, have taken on the shape of dazzling spirals, with arms extending outward from a bright central core. These are regions rich in gas, dust, and of course, stars. But the universe is not a static place. Entire galaxies can move around, attracted to each other, often colliding and merging in events of cosmic magnitude. These are the true titans of the cosmos in an eternal dance. And in a small spiral, in a not-so-remarkable region of the Milky Way, lies our solar system. Proof that, in the vast theater of the universe, even small actors have crucial roles to play. In the first fractions of a second after the Big Bang, the universe was full of seething particles. However, a quantum battle was about to unfold. At every moment, pairs of particles and antiparticles were created, only to annihilate each other in flashes of energy. In theory, they should exist in equal amounts. But here lies one of the great mysteries of the universe. If matter and antimatter were created in equal amounts, they would have annihilated each other, leaving only energy. But clearly, that didn't happen. For some reason, the cosmic scale was tipped slightly in favor of matter. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That small advantage was enough. The surplus matter particles formed the stars, galaxies, and eventually everything we know. And even today, scientists seek to understand this subtle skew in the nature of creation. As we move forward on the cosmic clock, approximately 380,000 years after the Big Bang, we reach a crucial phase known as the Age of Recombination. The universe, which was previously superheated and ionized, began to cool. Protons and electrons, which were previously separated due to high energies, now began to combine to form hydrogen atoms. This was a defining moment, For as atoms formed, the universe became transparent for the first time. Light, previously trapped and scattered by charged particles, could now travel freely. This first light of the universe, which we can still observe today, is known as the cosmic background radiation, a gentle echo of the dawn of time. It serves as a valuable window into understanding the conditions of the universe in its infancy. Astronomers study this radiation not just to explore the history of the universe, but to unlock the mysteries still hidden in its patterns and variations. It is a silent melody, a song of the cosmos, which we are still learning to interpret. As the cosmic vastness continued its ethereal dance, something magical began to happen. We were about 200 million years away from the Big Bang, and the stage was set for the birth of the first stars. Huge clouds of hydrogen gas and cosmic dust began to collapse under their own gravity. These collapses generated heat, and in their incandescent hearts, stars began to be born. The birth of a star is an extraordinary spectacle. In the hot, dense core, nuclear reactions ignite, turning hydrogen into helium and releasing incomparable energy. But the stars were not alone. They grouped together, attracted to each other by the force of gravity, originating the first galaxies. These majestic entities, filled with stars, gas, and dust, became the jewels of the expanding universe. Thanks to our eyes in space, like the Hubble Space Telescope, we can glimpse these primordial galaxies today, looking billions of light years across space and time, witnessing the infancy of our vast cosmos. Our journey through time and space brings us to the present and projects us into the future. What, then, awaits us? What does cosmic evolution have in store for the universe and, by extension, for us? There are several theories about the ultimate fate of the universe. Some scientists speculate about an eternal expansion, where everything becomes colder and more insulated. Others talk about the possibility of a big crunch, where the universe eventually collapses in on itself. The curious fact is that the expansion rate of the universe is accelerating, not decelerating. This brings us back to the mystery of dark energy, that enigmatic entity that makes up about 68% of the universe. Theories such as the Big Freeze, where the universe expands until all matter and energy dissipate, or the Big Rip, where accelerated expansion tears apart even atoms, are hotly debated within the scientific community. Regardless of the fate that awaits us, the quest to understand our universe remains one of the most exciting and humbling journeys we can embark on. And who knows? Maybe the end is just a new beginning. In the context of cosmic vastness, the Big Bang is not just the birth of the universe, but the prologue to the greatest story ever told, a story in which we are all an integral part. Friends of the cosmos, it has been an incredible journey today, navigating through the beginning of time and the magnificence of our universe. Thank you for being here, exploring these mysteries with me. If you like this video and want to continue this adventure for knowledge, don't forget to click the like button and subscribe to the channel. To the next.